Right. Good morning, everyone. Hope everyone is having a good day. Today, the first session of the second day of week 6. Today, we're going to be taking a look at vector databases, specifically with the Facebook AI similarity search vector database. Actually, it's not a full-fledged database, but rather, yeah, and the ChromaDB database, which is actually a database. So as usual, if you have any question, please just raise your hands or just go ahead and speak so that I will know there is a question. Let me just share my screen. Can you see my screen? Okay, good. Actually, let me just give me a minute. Yeah, I think this is better. Okay. Okay, so let's take a look at building a database, vector database to be specific, with ChromaDB and FAISS. And also we will have a demo session where we will take a look at just an example of using both and what is their upside and downside as well. Okay, so let's get started. So before starting, let's talk about what a vector database is. I'm sure all of you, if not, most of you, if not all of you, know what a database is. But a vector database is something that came into play with the emergence of AI. Basically, what it is it's just a specialized data store or database for efficient storage, management, and querying of high-dimensional numerical representations, which we normally call vector embeddings or embeddings in short. So your data is going to be embedded into high-dimensional numerical representations. So what this basically means is your data is going to be, it could be text, it could be image, it could be anything. It is going to be transformed into this numerical embedding or vector embedding, which we call. And the fundamental purpose of this vector database is to enable similarity search. So so they enable the application to identify items that are similar, semantically or contextually related or similar, rather than relying on exact word match. So think of it this way: when you type in the wrong word, or rather the wrong spelling of a word, you still get a match. So that's basically not a good example actually, but pretty much close, right? So your data is going to be converted into these embeddings, and your query is also going to be embedded into this or transformed into these embeddings. And these embeddings are going to be used to find any relation, or if they are close or not, right? So instead of looking for exact word match, you're going to be taking a look at their closeness in the so how close they are in this vector space, right? So we have this vector space where your vector embeddings are found, and you're going to be taking a look at or trying to find their distance. It could be their cosine similarity or equivalent distance that's found between them. So you're going to be taking a look at how close these two embeddings rather than trying to look at how finding exact word match, which is not suitable. So actually, as I've said earlier, these databases are directly related or linked with the evolution of AI. Because modern tools of text embedding like vector to word to vector and BERT generate these high dimensional vectors, which are the vector embeddings, right? And these vectors, these embeddings are not just numbers, but also capture these meanings and characteristics of the data, so that it allows the computer to understand what it means or what it contains, right? And this essentially is going to help the computer to compare the data based on this underlying meaning. So as you know, the computer does not understand it the word, but these vector embeddings are going to help it find the meaning or the characteristics that's underlying in the data to be understood by the computer. So this is a very crucial leap beyond the literal form, or as we have discussed on the earlier slide. So this drives the adoption of vector database is therefore the imperative for semantic understanding, like semantic search or semantic understanding, and contextual retrieval, which you are going to be working on for this week. So even when you type in a question for this week, actually, when type in a question, the one specified in the document, why are people not happy with the buy now, pay later product? These embeddings, so your question is going to be embedded into a vector embedding, and it's going to be, it's going to be compared with the existing compliance that we have provided you with, and it's going to this embedding or this database is going to help or facilitate the retrieval of relevant context to that question based on the embeddings. So it's very crucial, and it's a very good thing to know. Actually, Postgres actually have added this vector database into their product as well. So it's very good to know. So why are they crucial for modern AI applications? So as we have talked earlier, they form the foundational infrastructure for a system demanding information retrieval based on the semantic meaning. If you are working with exact word match or keyword match, or matching based on the words, you don't really need this one. You just need to query it and find the exact word match. But if you are looking for retrieving context based on semantic meaning or something that's close to the question, you're gonna definitely need it. So this is used for semantic search, anonymity detection, personalized recommendation system, and of course, what you're gonna be working with, the RAG architecture, and that's found in the large language models, and of course, RAG as independent as well. So some use cases, some examples of using this. For instance, ChromaDB is an API it's designed to be developer friendly, and it's designed for efficient management of large volume embeddings, suitable for semantic search, recommendation engines, and optimizing AI models like chatbots requiring real-time response and virtual assistant, while the Facebook AI similarity search is used to apply a recommendation system, image retrieval, and the natural language process, or NLP, and clustering as well. So, is there any questions on before we move on to the key components? Are there any questions on what it is and some use cases? No questions? Yes, Daniel.
Okay, thank you. My question is that so the LLM understands the embedded text, right? Like the array or
No.
float numbers.
Not the LLM.
Okay, so
The LLM is just a language model, not. Okay.
yeah,
Continue.
yeah. So so I have to unembed it while giving to the LLM, right? After retrieving the similarity, I have to
Yeah, it's
unembed it
already
while.
related. It's already related to the embedding. So the context and the embedding are related. So when you like, of course, there are some cases that you have to like return it, but most of them already have it related. So when you choose the embedding, you are actually going to choose or to retrieve the context as well.
Okay, okay. I need to retrieve the original text to feed the LLM.
Yeah, of course. It's going to give you also the original text, and you will use that one. Okay. Desktop, can you use this DCP for business application? Of course you can. You can use these databases for commercial purposes as well, but they are not ideal, I would say. I would recommend you to use depending on the business actually. If you don't really need embeddings, why would you use them? But if you want, yeah, they can be used. I think I'm not really sure about these two. I know ChromaDB can be used, but I'm not sure about the Facebook AI similarity search, since it's not a database, but it's more of a library. I'm not sure about it. But for the ChromaDB, like Wave 8, I'm sure about Wave 8 because I also use it as a database sometimes, of course, if needed, but it's not ideal. Like the bottom line list is not ideal if you don't really need it for this use case, but for some cases, yeah. Yes, Gabriel.
Okay, thanks. My question is, can we access the vector database like other, like Postgres? Can we access the real data?
For these cases, I'm no, but for some databases, yes, you can. I haven't tried for these ones, to be honest. Maybe I will, but I haven't tried it, to be honest. I've tried it with Wave 8 and others. You can query it and get it, but I'm not sure about this.
Okay.
Okay, good. So let's talk about the key components of the vector database. I think this table actually summarizes it very well. So the first function or the component, the key component is the embedding function. Sorry. So I think this is related to what Daniel asked. So this transforms the raw data into the numerical vectors. This is what converts, the data into a format for similarity comparison, which is the vector embeddings, and then similarity metrics. So this quantifies how close or similar the two vectors are. So we have some matrices that we can use. So it identifies similarity for an application, implicates search relevance, and so on. And then we have the indexing. So this is going to organize the vectors for efficient retrieval or the nearest neighbor. It depends on the number you give it. If you want the nearest 5, the nearest 3, and so on. So this is crucial for performance and scalable with large database especially. And of course, we have the metadata. So this is additional descriptive attributes stored alongside the embeddings for precise filtering and contextual refinement for search results. And lastly is persistence. So ability to save the vector database state to disk or to reload it is another core component. So yeah, you can take a look at some of the examples here for the similarity metrics. We have the gradient distance and the cosine similarity that are the most, I believe, the most ones for quantifying the closeness between vectors. For the indexing, we have ANN, which is actually the Facebook AI similarity search built upon and built for in the metadata and the persistence. Okay, so let's talk about the two example. The example vector databases we have for this week. Of course, you're going to have to choose between them. And I just prepared this to help you, like understand them and help you choose the right one for you. So the Facebook similarity, the Facebook AI similarity search is a library, not a full-fledged, database. So you're going to have to be responsible for, the managing the data persistence, associating filtering metadata, and constructing surrounding infrastructures. So it doesn't have a built-in metadata storage. It doesn't have a complex querying. It doesn't have transactional support. It doesn't manage the data extraction as you would expect a full-fledged database would have. So it's implemented in C++ and used as a comprehensive Python wrappers, like with a constant Python wrapper, and it's fundamentally a library for ANN or approximate nearest neighbor search. So this has a big impact. So why is it built? So it's built for 4 reasons, its main thing is speed. It's very fast. It has actually both CPU and GPU. It's built for both CPU and GPU. Of course, we're going to take a look at the CPU one. So for the scale, the speed, it achieves industry-leading performance through high optimized algorithms. So it's efficient data structure and substantial hardware acceleration. So GPU implementation is also available. When you download the Facebook AI similarity search, you will have 2 options: the CPU and the GPU. Or when you install it, I think I said download, but rather install it. So it's engineered to manage data sets. So scalability, it can be scaled from millions to billions of vectors. For accuracy, it's less accurate actually, but it provides a flexibility to balance the search speed and the with precision. So allowing the fine-tuning of indexing methods and parameters. And it's versatile and can process diverse data types such as image, text, audio, and once transformed into high-dimensional vectors or the vector embeddings, it supports various distance matrices as well. So there is a thread. This database actually library actually has the ability to trade precision for speed. So you can evaluate the trade-off between speed and accuracy or mixed memory usage. So it's super fast, but you can trade off this speed for accuracy, basically. So when we come to ChromaDB, it's a full-fledged database which is designed to simplify the storage, management and query of vector embeddings. So unlike the FAISS, it provides more integrated database experience. So it's persistent. So it saves this in the memory. It also have metadata management, which the Facebook AI embeddings or similarity search doesn't have. And if it can also have embedding, it can also embed or create embeddings internally by using, of course, you can choose. So it's built for ease of use, persistence, metadata management, and building embedding by using like mini LM and others as actually, but the mini LM is the default one. So it's an API designed to be minimalistic and friendly, user-friendly, featuring for premier functions such as adding, like updating, deleting, and searching for vectors. So it's persistent. It's an in-memory database, so you will have fast access time. It supports storing metadata, and of course, it has also built-in embedding modules. So it's focused on ease of use and integrated features make it attractive options for organizations seeking straightforward implementation without sacrificing functionalities. But of course, it says it's easy to use, but for me personally, I think setting up and using the Facebook AI similarity search is a little bit, I would say, easier and faster compared to the ChromaDB. Okay, so here actually are most of them are just, you know, a duplication of the what we have seen in the introduction to these two databases, just the pros and cons. So for the pros of the Facebook AI similarity search, it has high optimization for speed. And the GPU acceleration is actually 5 to 20 times faster. It has a fine-grained control, so it's a wide array of indexing method for parameters of precise tuning. So what's interesting about the Facebook AI similarity search is it has, I think, around 4 or 3 different types of indexing methods that you can use depending on your like the size of the data, the data set, or the speed that you want it, and of course the metrics that you want to evaluate it against. So it has that option. It's scalable. It can be scaled to millions to billions of vectors. It's versatile. It supports multiple matrices and different types of data, and it's open source. So it's that's good. But the cons also include it's not full-fledged, or it's not a full database. It's high complexity and may have some learning curve, not built. It doesn't have a built-in metadata management, which is a bit hard when you work with LLMs like for RAG and so on. No built-in. Okay. Yes, Gabriel, is that a question? Okay. And manual scaling and requires training for many instances. And for ChromaDB, when you come to it, it's designed, I would say designed in codes for ease of use and a simple API. Yes, Daniel?
Okay, that means that when we are using FAISS, we should have to store the metadata on another database?
No. It's going to, like it has an in-memory support. It supports and in memory, like it doesn't support it as a standalone service, but you can store it. But we will see like the adding and like the deletion and that stuff are not ideal here.
Okay.
Like, or it cannot extract data like you would have in a normal database. That's the biggest. You cannot delete it, like things like that.
Okay, thank you.
We will see in the example actually. Yeah. Okay. So it has integrated database functionalities that the Facebook one doesn't have, it handles persistence, metadata management, and can generate embeddings internally, which is good. The metadata management, internal metadata management, both are actually open source, and it's good for rapid prototyping in small projects, but it's not, like scalable as the Facebook one. Potential high resource intensity, like less fine-grained control, and doesn't support transactional or analytics use cases. So when choosing, you have to take into account this a lot of things actually. For example, scale of data, how much data set are you planning, like to use? The performance requirements. So if you want absolute peak performance, minimal latency, and high throughputs, the FAISS is the FAISS is your choice because it has high speed. Ease of use, if you are looking for ease of use, the ChromaDB is your go. If you want more control, you can go to the Facebook one, and if you want more convenience, you can choose the ChromaDB. If you need out of the box, like internal metadata management, you can go with the ChromaDB, and of course, the existing infrastructure also matters here. Yeah, so that's it for conclusion. From what we have seen, so these vector databases like bridge the gap between raw data and semantic understanding. So from the raw data, they can like understand or extract semantic understanding. They enable systems for efficiently find and retrieve information based on meanings, power crucial functionalities like semantic search, RAG, recommendation systems, and so on. So you can use the FAISS or the Facebook AI system, semantic search as high optimized, low-level library, excellent in raw performance, memory efficiency, and scalability for massive dataset. Especially if you are using, if you have a GPU acceleration, it could be 5 to 20 times faster. And it provides unparalleled control over indexing algorithms. And for the ChromaDB, it's designed to be developer friendly. It simplifies working with vector embeddings by providing built-in persistence, metadata management, and intuitive API. So depending on your project demand, you can use either one of them. Yeah, so that's it from my side. Any questions? Daniel, the ChromaDB is better for this project then. I would not like conclude, but like as we have seen, ChromaDB is normally used for chatbots, like more used for chatbots. So it looks like it. Yes, I'm doing good.
If I'm not wrong, around slide 2 or 3, FAISS is suitable for chatbots related project. Maybe our project is including chatbots, so our should be that DB.
No, I was just saying that since we are going to be working for chatbots, the ChromaDB could be the go-to. But it depends. Like, take a look at both of them. I will give you the notebook where I have implemented both, and you can take a look. For me, yes, the ChromaDB is better because it has also a database functionalities. But yeah, it depends on you and on your system. So for those of you who's, like who doesn't have that much memory and so on, maybe the Facebook AI similarity search is better. So it depends on your requirements. That's why I try to use both in that demo.
which one has a learning curve? Is Chroma or
I would say the Facebook AI has a slight learning curve than the ChromaDB, but most of the things are related. But yes, I would say the Facebook AI similarity search has some learning curve.
thanks?
Okay, thank you. Yes, Daniel.
Yeah, I'm sorry I had to ask so many questions.
It's okay.
Okay,
I like it.
So after cleaning and chunking the compliant narrative, we should embed each chunks into the vector, right?
Yes.
So attaching the metadata like the compliant ID or product type as it's listed on the documentation. I'm not entirely sure about it, but should I store the original text with the metadata, or should I store just the compliant ID? And when I try to give it to the LLM, should I retrieve the from the data set using the compliant ID, or should I store it on the metadata, the original text? Which one is the
So
the better
when you say the
option?
original text, you mean the cleaned, right? The cleaned data.
Yeah, the cleaned and chunked data.
Yeah, so you have the cleaned data and you want to, like, you have embedded it and you're asking if you have to include the ID into the metadata or in the data. Is that correct?
Yeah, should I include the compliant ID on the metadata, or should I include the original text?
For the metadata, actually, instead of the original text, I would suggest that you include the type or the product. And I think there's also another thing that you can include. But for the metadata, I would rather you include the product type. Like, is it like for the credit risk, like for the credit card, is it for calculator, and so on and so on. And like, I think it has also, I forgot the column. Let me check actually.
Is it compliant ID or something like that?
No, not compliant ID. I don't think so. Just give me a second. So a short issue label, right? You have a short issue label, so you can actually use that as well.
Okay.
And the product,
okay.
yeah.
Okay, can I ask another question? I mean, it's just a bit off, but can I ask you that?
Don't worry, just ask. You can ask.
Okay. Okay, this question is that you say that top K similar complaints. You give us like as example 5, but my question is that if the compliant narrative is long enough, and I try to chunk it like more than 5, and while doing similarity search and try to retrieve it from vector database, what if that it chooses 5 of them from one compliant?
It's not going to be individual. It's not going to be individual, right? So you have the chunks, and when it is retrieved, it's going to be one. I think if we take a look at actually the example that we have here, I think it's going to be very much clear. I believe.
Okay. What if those chunks are from one compliant? Like, if the compliant is long enough, it will be chunked more than 5, right? Yeah, it will be more than 5 chunks.
But they will be grouped together. Yeah. Okay. Continue.
Okay. Then, when I try to select the top 5, what if those similar compliants are from one long compliant sentence?
So for chunking, you are assuming that each chunk is going to be one embedding individually.
Yes.
Right?
Yeah. Yeah.
But that's not going to be the case.
Okay.
Yeah, I think
Okay.
it's good. Okay, continue. I don't want to stop.
Okay,
you.
that means I'm going to store on the database the merged embedded.
You're not going to store. It's going to store it itself. It's not a manual thing. So you're gonna turn it into lists, and that list is going to be seen as one list, not different lists.
Okay, so there will be a similarity between chunks.
Of course.
Okay, thank you. This is my question.
So let's. Yeah, I think that's a good question, but I believe it's good if we take a look at the examples. I think some things are better explained with a demo. That's why I just wanted to move here. Okay.
No.
But it's an excellent question. Yeah. Okay, Desktop, can you share? I have lost access to my Gmail account and I'm unable to access Gmail. Okay, Desktop, can you just contact me on Slack? Okay, go to Slack and DM me and I will send it to you there because it's a big chunk. If possible, can you explain a simple scenario for usage of ChromaDB on chatbot? I mean, like the few steps how data is cleaned, saved on Chroma, and retrieved. Okay, okay. Let's see the demo, and we will come back to see the symbol if it is not clear. Okay. Okay. So here, like for this demo, I will use both ChromaDB and the Facebook AI similarity search. Here I have imported the Facebook AI similarity search for CPU, not GPU. And here for the embedding, I have used the mini LM model from sentence transformers. In this, the model's embedding dimensions are 384. So the words are going to be embedded into 384 dimensions. And the maximum sequence length is 256, and so on. So here, for this example, I have, I will actually convert this into a data frame, but we have the name of the buildings, or like the landmarks, their description, the Eiffel Tower, and so on and so on and so on. Their description, their location, and their continent here. So if we convert it into a data frame, you'll see Eiffel Tower. The Eiffel Tower is the its description, its location in its continent. So yeah, for these descriptions, if you can see, it's some of them are very long, and so on. So here I have embedded it by using the embedding. I have actually embedded the descriptions. So I convert it into list and embed the description, not the whole thing, right? So the embeddings of the descriptions are 15 into 384 dimensions, because the dimension of the model was 384, and we have 15 landmarks, so it has 15 by 384 dimension. So mind you, we have actually embedded the descriptions, right? So here is just like a visualization of the landmarks in just a 2D. So we have the Golden Gates. So this is just trying to show their embeddings from their descriptions. So you can see the Golden State, the Statue of Liberty. The green one are the North America. The blue ones are Europe, Africa, and so on and so on. So you can see their embeddings and like just a 2D visualization of them. So we have embedded the description. So as you are like Daniel, this was what I was trying to show you. So we have embedded the description. Some embeddings are long, some embeddings are short, and but it's going to be 1, right? So for the Taj Mahal, we have 1. Sorry. Yeah, sorry for that one. Yeah, so this is just to show their, descriptions, their embeddings. So for the embeddings, let's create the Facebook index, the Facebook similarity search index. So here I have used the first one for the shape, and I have used actually the index flat LM. There are different types of, indexing for the Facebook AI, the FAISS, I think I would call it that. And if you take a look at here, what I'm trying to do is I have created a function that's going to take in a query and is going to return the top 3 results from the embeddings, right? So I have created an index here, and so it's going to take the query and it's going to encode it by using the model. So it's going to embed it by using the same model that we have used to embed the description. And it's going to take, have to search by using the query embedding. So it has the query embedding, and it's going to use the index to search the top 3 indices, right? So that's what we're going to call them, indices. So, and it's going to return also the distance between the embedding, the query embedding and the index. Okay. So here it's going to give us the result, and it's going to give us the landmark name, the location. So these are the things that we have in the original document. So for the query we have, so it's going to, so this is just going to return it in a data frame and so on. And for the query we have ancient monument in Europe. So we have Europe, so it's going to modern skyscrapers, landmark in America, and historical state of Asia, right? So when you apply these queries into, the function, the search with FAISS function that we have defined here, here as the result. So here for an ancient monument in Europe, we have, so it has returned 3. So it has returned the Colosseum, the Mount Rushmore, and the Petra. So this is correct. The Colosseum is correct, but the rest are not correct, right? For modern skyscrapers, we have Burj Khalifa, and the Eiffel Tower, and Pyramid of Giza. So the first one has the shortest distance, and which is the correct one, but the rest are not correct. Landmark in America, so we have the Statue of Liberty, and we have the Mount Rushmore, and we have the Petra, which is in Jordan, but it's the closest than the rest. So it's going to choose it based on the distance. Okay, so this is the distance between the query. So it's the distance between the query and the description. Okay. So Statue of Liberty, Mount Rushmore. So let's see, Statue of Liberty, Mount Rushmore, and where is one? So the Petra is on that dimension. They are the closest one. So it's going to retrieve them. So this is just an example of how you can use the Facebook AI similarity search. Of course, as I've told you earlier, there are different methods of indexing, creating index for the FAISS. So for these two, we can use we can see, the flat L2 and the flat AI IP or internet product methods. And actually, you can read here their use cases, and here for the example, for the query famous tower, we have to encode it into by using the same model that we have used to encode or to embed the description. And for that, when you take a look at their, like the result, actually the result is the same, but their distance is very different, right? So here, the distance is very far than you can find here. So these are just, don't worry about them, it's just for example purposes. Yes, Daniel?
Can you share us this notebook? Is it
Of course, it's
possible?
always shared. It's also always shared after the session is over. It will
Okay,
always be shared.
And also the similarity is based on the Euclidean, right? It's not cosine similarity, because
Yes.
yeah,
Okay, continue.
yeah, because the number is, when the number is decreasing, it's better, right? When you
For
are using
the
Euclidean.
IP? For the IP?
Yeah, the distance, yeah.
For the LP is L2, yes.
Okay.
So there are different indexing methods for both. So that's why it's considered flexible. It can have different matrices built in it. Okay. So that's just the example for the FAISS. And when we come to the ChromaDB, what you have to do is you have to create a collection, since it's a full-fledged database. Like it has the functionality of a normal database. So here we have to create a collection and a client. So here first we have created a client, and for the client we're gonna have, so first, if it already exists, I'm gonna delete it since it's a demo. But of course you don't have to do this. You have to pass this one, but you can create a new collection. And for the collection, you have to give it the name and description. That's optional, actually, as a metadata. So for the name, I have given the collection landmark collection. The name of the collection is the landmarks collection. I think I have made it confusing. But yeah, so it has created the collection, landmark collection. The name of the collection is landmark collection. And here to prepare, like I have to convert it into, like to list. And for the metadata, I have used the name, the location, and the continent as a metadata. So it has, like we have discussed earlier, it has a built-in metadata management system. So you can actually include the metadata in it. So this is why it's better for the RAG that you are going to be building, and also as a RAG use cases. So here I'm going to add. So as we have talked earlier, it has add, update, delete, and search. Like query into the database, since it's a database. So I'm going to add the embeddings. So here I think it has not created an embedding, but it's adding to the collection embeddings, the document, the metadata, and the IDs. So the IDs are just the IDs, then the number of, like from the link is going to take in the numbers, landmark 1, landmark 2, and so on, up to 15. So it's going to add them. So here it's going to take in, like it's actually the same or similar thing that we have used in order to, while working with the FAISS. So it's going to have taken the query, and for that query it's going to embed it, and for that embedding it's going to query, where by using the query embeddings as the query embeddings and the number of results as the 3, and where like if you have multiple properties where this property is equal to this, like just a normal querying, where like when you use SQL, you will use where, right? Where this equal this. If you have different properties, since we have only one, which is description, you don't have to have it. So I have used none. So it's a similar thing from there. And here we have ChromaDB search answer ancient architectures, ChromaDB famous architectures, where if you have a where is the continent? So the continent is the property from the metadata where the continent is in Europe. So here, what you are doing is you're gonna be from the metadata, you're gonna filter the Europe ones, and from that ones, you're gonna have the famous monuments, and so on. So here it should be better because of the metadata that we have introduced. So in ancient architectures, we have the pyramid of Giza, the Jordan, the Petra, and the Colosseum, and from the famous monuments in Europe. So, of course, we didn't include it in the query, which makes it not fair. But since it has a built-in metadata management system, we can use that as for our advantage and search it where the continent is in Europe. So here, it should give us a good result compared to when we try to use the FAISS, because if we take a look at it here, so here modern scrapers, so here ancient monuments in Europe. So I asked it in Europe, but it returned Mount Rushmore and Petra, which are in US and the Jordan. So here, since I have used the metadata or a filtering mechanism in the query, so it's going to take a look at where continent is equal to Europe. So it's going to return the correct one. And here also, where it's Asia, so it's going to return the Asian buildings. So it's very like the built-in metadata system is very ideal for these things. So for speed, the FAISS is very fast. Of course, the ChromaDB is also fast. The FAISS doesn't support or it doesn't have a built-in metadata management system that the ChromaDB has. For persistence, like the ChromaDB is better since it has a built-in, but the FAISS is not standalone, easy to use. Both are easy to use in my opinion. For scalability, the FAISS can scale to up to billions. So it's very excellent, but the ChromaDB is normally used for, like small scale use cases or, for the demo purpose. The GPU support, the FAISS support this GPU, which makes it 5 to 20 times faster, while the ChromaDB doesn't. And for query flexibility, the FAISS is limited, especially since it doesn't have this metadata management system as well. And for memory usage, so it's very low memory usage compared to the ChromaDB. So just to demonstrate, it's just a function that's going to calculate the time of each run for each, query. And here you can see from the average, the FAISS only took 0.07 millisecond to complete search, while the ChromaDB on average created or used like almost 2 milliseconds to search on average. So it's very, very different. So it's very, very fast, the FAISS, but considering like the flexibility and other things, maybe the ChromaDB is faster. Yeah, it's very fast. Plus, it's built on C++, so it should be fast. Yeah. Okay, so that's it from the demo side. So is that clear, guys? Just to check in with you guys, is it clear? Do you have any questions? Okay, good. So Simbo, is that clear now? Like I just wanted to go through just the use cases. Hopefully that's good. Okay, good. What about Abdulaziz? I think. Okay, good. Thank you for asking as well. Okay, good. Okay, good. So any quick questions before I close the session? Do you have any questions? So I'm going to share. I think I'm going to include a couple of references on the on these slides, and I will share it within an hour or two. Yeah, just look for it in the drive. Okay, look for it on the drive. Okay, I will inform the team, and we will upload it. Yeah. Okay. Good. If there is no quick questions, I think we can end the session here. Which dataset desktop? Yeah, like I've said, desktop DM or message me on Slack, and I will send it to you. Okay, good. Okay, thank you guys, and have a great day. See you guys on Slack.